Hello, my name is Thomas Feiner. I'm the founder and the director of the Institute for EEG Neurofeedback in Munich. Our institute has become one of the leading providers for neurofeedback education. And in our own research lab, we develop tools and programs for trainers and researchers in the wide field of applied neurosciences. Our most recent project was to create a system which allows to measure event-related potentials in a much easier and more comfortable way.
I'm now showing you the system we have developed in our lab, which can present auditory and visual stimuli with minimal effort. So even beginners in the field can have an easy start with stimulus presentation using the system for ERP measurement we have created. But also advanced users will benefit from our system. The jitter produced by Windows cannot be accepted and generates inaccurate results. Therefore, a technology called transistor logic is needed to get accurate data. Our system addresses cognitive event-related potential at first, like measures for P300, MMN, FRN, ERN, CNV, and others. The system consists out of several hardware elements, mainly the trigger box and the photosensor, which you see on the left side of this picture. And on the bottom, you see the trigger box with the push buttons for motor response or for testing purposes. And on the left, there is a photosensor with two photodetectors, which are attached on a monitor, which you see here on the right side is the photosensor attached to a monitor, and underneath you see the signal and the markers that are produced by the presentation software. These markers indicate trigger information for the photosensor. The photosensor will send the recorded information to the trigger box, where it then is produced, where it produces electrical signal and sends it to the EEG device via cable. So the result is a minimum of jitter and a maximum of accuracy for obtaining accurate results for the triggers and for the averaging of the EEG, which is done later by our ERP-Analyzer that will be presented by Dr. Garner, who is one of the developers of the ERP-Analyzer in our lab. This is the GUI, the graphic user interface of our trigger presentation software, of our stimulus presentation software, which when presentation is started, it sends the trigger marker simultaneously to the screen, and where it can be detected by the photosensor. These markers then are sent to the trigger box and then further to the EEG device. I have already shown this in the previous slide. Here we have some buttons where the user can just use predefined stimulus presentation protocols, but there's also many options to create the optimized individual stimulation protocols, which we will see in the next slide. So one of the very simple things you can do with this tool is just to create a simple visual oddball paradigm. And here is how it looks like in the screen of the software in the graphic user interface, where you have several options. And let's look at the top here. There is a picture presentation selected, but in the drop-down menu, you can also select visual, also auditory stimuli for presentation, like tones and sounds and so on. The colored boxes, we call them boxes, are places where where several stimuli can be chosen, and clicking on the plus button here opens the stimulus library for pictures in this case, and you just select the pictures you like to present in the protocol, and then it will appear in the box for common stimulus, or in the box for the uncommon stimulus. Here it is said we clicked on the green box, and then we select the stimulus for the common stimulus. If we click on the red box, we select the stimulus for the uncommon presentation for the rare stimulus. So, and if you click inside of the white box, you can then select and choose a picture or a stimulus from the library, which then will present a neutral stimulus. This is important because the software from this box will just know, the software will know which marker it will produce. The marker on the screen that where does the photosensor can read the marker information, whether it's an oddball or a frequent stimulus. Okay, and further down we have the presentation, the number of trials of the presentation. We have chosen 130 in this case. Number of trials, that means 130 times there will be a stimulus presented, and it can be a common or an uncommon stimulus. And here we define how often the uncommon stimulus or the target stimulus should appear. And here we decided it should be 20% of the whole number of the presentations, and it will be there will be 26 presentations of the uncommon stimulus. Also, the trial duration, of course, can be defined, and here we have chosen 1,000 milliseconds. It can be, of course, more or less, and there is a stimulus duration you can define, and well, there can even be an interval between the trials that can be chosen randomly. Here is a possibility to choose random, and then all these stimulus presentations will come randomly. Okay, we call this also a jitter in between the trials. This is a very simple way how to set up an oddball stimulus protocol with visual or auditory stimuli. The next thing we look at is the single stimulus creation of a presentation, and this is done in this way, where we still have the same boxes where you define which stimulus should have which characteristics. Here we choose the O letter as a common stimulus, and in the next, when we saved this stimulus presentation protocol for this one stimulus, we just switch them to the uncommon stimulus, which is which is then shown here as the Y button. Shoot. And the same way it can be done with the uncommon stimulus. We click on the box where we want to place the uncommon stimulus, and we select the letter Y picture from the picture library, and we can use the same setting, 1000 milliseconds for trial duration, 500 milliseconds for stimulus duration. There is 100% target, of course, because we always want to see the target when we only want to have one stimulus, and there is no interval in between. But of course, in the countdown, you can define a certain onset time so that there is a pause between one presentation and the other presentation, or the one between one trial and the other trial. So now we have two trials defined, one for the common, the other for the uncommon, and we can also create a stimulus protocol using the single trials we just defined. And here on the left, you see that we already have a collection of single trials or of tests, and we can use them always later in our session protocols. And the longer you work with the software, the more possibilities you have collected, and then you can create protocols from a collection of trials you have already in that folder. Okay, then let's go to the next slide. Then there is the presentation of sessions, how you can create sessions, which has more complex presentation structures. Okay, and here you see left there is the structure that consists out of 11 different trials, and one trial is a sample shown. Oh, sorry, there is a sample shown. There is fixation cross. There is a match picture. Then there's another fixation cross at a different duration with 2,250 milliseconds. Then there is another match picture, and this is actually one of the tasks we are working at the moment on, so-called delayed match to sample task. And in the session list, there can be like 100 or 200 or more several trials and single trials that are defined in the test section, which some also call the stimulus library or the stimulus list here. But this is not just a stimulus, it's those stimulus presentations are already defined, whether they are a common or an uncommon stimulus or a neutral stimulus. Okay, and the session task, the test sections inside the session can also be very well be modified and edited. You can add other trials or remove trials or change the order of the trials whenever you need to do this, or whenever you think you need to optimize a protocol, or you found an error in it where you want to remove or replace a several trial which you found which is not working or which doesn't fit your purpose. And of course, you can assign presentations to subjects, to several subjects, which is also a possibility inside the software, where you can define a subject name or create a subject folder in which you can add other stimulus presentation protocols. The meaning of event-based potentials for clinical research and practice increased, and research shows the value of such findings. ERPs present promising tools for evaluating the biological source of functioning of the brain in many neurological and psychiatric disorders. And here are some examples of research and findings which we think are very important. We think because of this, it's about time that the enormous potential of this method will be more and more established in clinical practice with easy-to-use methods for both the researcher and the clinician. At the end of my talk, I want to thank all the great people in our team and the collaborators who helped us so much to move forward with this project. And thank you very much for listening and your attention.